Have you ever experienced your Power BI report break when you load more than one table? Or why do totals look wrong in your visuals? The answer lies in something foundational: relationships between tables. Today we are going to break down the theory behind relationships, so you don't just have to follow steps, you understand them. Let's start with the concept of relationships in data. In databases and BI tools, a relationship defines how one table is connected to another. Imagine two Excel sheets, one for customers and one for orders. How do we know which customer placed which order? The answer lies in the shared column, like the customer ID. This shared field creates a logical connection. Think of it like Lego pieces. When a column matches across two tables, they click together. This connection is called a foreign key relationship in database theory. Without relationships, your system treats each table like an island. What that means is that filters won't work across tables, aggregations can become meaningless, and you might see duplicates or wrong data. Relationships are like the logic gates of your data model. They let data flow in a structured and meaningful way. The concept comes from relational database theory, which forms the backbone of tools like Power BI, SQL, and even Excel pivot tables. By definition, a relational database is a way of organizing data into tables that are connected to each other using unique identifiers like a primary key or a foreign key. These connections show how the data in one table relates to data in another. Relationships also have direction, which affects how filters pass between tables. In a single direction relationship, filters flow one way. They're safe and the most common ones used. In a bidirection relationship, filters flow both ways, and you have to use it only if necessary. This reflects the flow of logic, like which orders belong to this customer, not the other way around. There are three most common types of relationships: one-to-one, one-to-many, and many-to-many, which requires a bridge table. We're going to discuss that in the next few slides. Now let's talk about the one-to-one relationship. This means each record in table A is connected to only one record in table B, and each record in table B is connected to only one record in table A. Let me show you with an example. Imagine we have an employee table with basic details like name and department. And then we have another table called employee login details where we store their email and login username. Now, here's the key. Each employee has only one login, and each login belongs to only one employee. That's a perfect example of a one-to-one relationship. We use the employee ID in both tables to connect them. So if we want to see an employee's login info, we can connect the tables using this common field. In Power BI or any other data model, this helps us separate sensitive or technical information from general employee data, while still being able to link them together when needed. So just remember, one person, one login. One login has only one person connected to it, and that's a one-to-one relationship. Clean, clear, and super useful when organizing secure or detailed data. Now let's talk about one-to-many relationship in data modeling. This is one of the most common and important relationships you'll come across when working with data. Let me explain it with an easy example: customers and sales. So imagine this. We have a table called customers and another one called sales. Each customer can place many sales orders, right? But each sale belongs only to one customer. This is a classic one-to-many relationship. Now, say we have a customer with the ID C005. Let's call him Daniel. In our customers table, we have just one row for Daniel. But now, in the sales table, Daniel shows up multiple times. So what's happening here? One row in the customer table, Daniel, matches many rows in the sales table because he has different purchases. This is exactly what we mean by one-to-many. One customer, many sales. but each sale has only one customer assigned. And in tools like Power BI, we build this relationship by connecting the customer ID field in both tables. We set the relationship like this. One side from customers, many side to sales. Once this is set up, we can do really cool things like see the total sales per customer, filter the sales table using customer names, create dashboards that show which customers spend the most. So always remember, if one item in table A is connected to many items in table B, and those items in table B connect to only one item back in table A, that's a one-to-many relationship. Let's talk about something important in data modeling now. It's called the many-to-many relationship. Now don't let the name scare you. It's quite simple once you get the idea. Let me give you an example you all might know. Students and classes. Each student can join more than one class, right? And each class has many students in it. So it's not a one student to one class. It's many students to many classes. That's what we call a many-to-many relationship. But here's the tricky part. If we try to put this information directly into just two tables, one for students and one for classes, it gets messy. We'd have to repeat data and our table and data would become hard to manage. So instead, we use something called a bridge table or a linking table. This table simply records who is in which class. It does not hold any extra data or details. It just keeps track of connections. Let's say Ayan is in math, chemistry, and computer class. Then our bridge table will have one row for each connection. As you can see here in the image, it's like a list of all pairings. This makes it very easy for our data tool like Power BI to understand and analyze everything correctly. Students to many classes and classes, one class to many students makes a many-to-many relationship. We connect them using a bridge table to keep things clean and organized. And this is how a many-to-many relationship in databases work. It's simple, isn't it? Now let's practice building one in Power BI. So we've created two tables, one the classes table and the other the student table in Power BI. We can clearly see these two tables in the table view in Power BI desktop. Now let's go to the model view and see how these two tables have been connected. Once we click over here, we see that there really is no relationship shown here that has been automatically detected by Power BI desktop. So to see what kind of connection can be created between these two tables, we will click on this Manage Relationships button at the top. When I click here, it shows me no relationships have been defined yet for these two tables. And when I click on Auto Detect, no new relationships have been found because Power BI is not really able to find any foreign key that matches either of these two tables and are contained in both of these two tables. So what do we do here now? As we spoke earlier about the bridge table, that's exactly what we're going to do. We're going to create a new table which will act as the bridge table between these two tables that we have, student and classes. Let's go ahead and quickly create this table. As soon as we create the table, now you can see that the relationships have already been created on their own and our student and classes table can clearly be seen as connected to the bridge table. Let's open this table and see what it contains. Coming to our table view here, if I click and expand on the table, it is showing us the table that we saw earlier in our PowerPoint slides, where one student record is connected to many classes and similarly each class has many students connected to it. Looking at the model view, we can see that Power BI has automatically detected the relationship, and if you would like to make any changes, you can go ahead and click on the Manage Relationships and make any modifications required. Now let's talk about something that often confuses beginners: inactive relationships in Power BI. Let me explain this with a real-world example. Imagine we have a sales table here. Each sale has two important dates: the order date, when the customer placed the order, and the delivery date, when the product was delivered. Now, we also have a dates table here, which helps us analyze things like monthly sales or delivery trends. Here's the problem. Power BI only allows one active relationship between two tables at a time. So, we connect order date to the date table, and this becomes an active relationship. But what if we also want to analyze by delivery date? This second connection exists, but it's inactive by default, which means Power BI won't use it unless we manually activate it in a data analysis expression formula. It's like having two roads from point A to point B, but only one is open for daily use. If you want to take the second road, you have to request a special permission. In Power BI, we use the user relationship function in DAX to temporarily activate the secondary road. So remember, you can connect both dates, but only one works actively by default. And you need DAX expressions or data analysis expressions to use the other one. This gives you flexibility and control in your data model without causing confusion or calculation errors. I will create another video explaining the data analysis expressions, also known as DAX. So let's summarize the whole thing. A relationship is a rule that defines how tables are logically connected. It's based on matching values, usually keys. Power BI lets you design these relationships visually. The logic comes from relational databases, and it's the heart of data modeling. So next time you build a report, ask yourself, how does this table relate to the others? Build with that in mind, and your reports will be smarter, faster, and more accurate. Do subscribe, share, and follow our content on YouTube, and thanks for watching today. Goodbye.